Our next type of reaction is a double replacement reaction or a double displacement reaction. Um, I like to call these, it's a pretty silly name, innies and outies. It has nothing to do with belly buttons. And it's just my silly way of remembering this. So, all these reactions that we're going to be looking at in double replacement are going to be aqueous reactions. Just another little side. That means that the ionic compounds are going to be dissolved in water. And we've done this before. You remember we did the precipitate lab. That's another very important piece to this. You can tell a reaction's happening if you see the formation of a precipitate, and you have to use those solubility rules, that sheet that I showed you last time, on how to determine if one of them actually forms a precipitate or not. We'll talk more about that when we do balancing equations for this type of reaction. So remember to go to your textbook, find the definition, kind of just explain it to you. You can fill it in from there. I'm going to use this format that we've used previously, where we've got a make-believe compound RS. It's an ionic compound, so that means there's a cation at the front and an anion at the back, if you will. And RS is in solution, it's aqueous, and we're going to react it with make-believe compound T capital U. And again, remember, cations, the positive ones are first, just like on the periodic table. Positives on the left. The U is the anion. It could be a polyatomic ion, it could be just a non-metal. What ends up happening, and here's where the innies and outies thing comes from. It's kind of like, you probably remember how to do FOIL from your math classes. I draw my arrow backwards. Innies have the possibility, so remember, these are dissociated in water. There's positive R ions and positive T ions and negative S ions and negative U ions just floating around all together. They're soluble in the original combination, but sometimes when this cation combines with this anion, remember, cations have to be at the front, sometimes we create an insoluble precipitate, and that's the interesting part. So where's the outies part? The R can go with the U. R, U. R is the cation. Use the anion. Okay. So you start out with two ionic aqueous solutions or compounds, and you end up with two different ionic possible compounds. Now, sometimes when you put things together, they don't precipitate out. They're still soluble. So sometimes all you have is a whole vat full of 4 different ions, but sometimes they precipitate out. So my example is going to be potassium carbonate, barium chloride. And so you know potassium's a metal, it's going to be a positive. Barium's also a metal, it's also going to be positive. But potassium's a +1, and we have 2 of them. Barium's a +2, we have 1 of them. The carbonate ion is negative, and you know it's a -2. Chloride ions are -1, and we have 2 of them. All right, so where's the innies and the outies? I like to start with the positive going with a negative. Well, barium's a +2 and carbonate's a -2, so they're going to go together 1 to 1. And then the other one is the outies part. The potassium can go with the chlorine and make potassium chloride. Remember, potassium's +1, chlorine's a -1. Their simplest formula, they're empirical, and, well, technically they're not molecules, but anyway, their simplest formula is 1 to 1. However, we have 2 potassiums and we have 2 chlorines, so this is not balanced. And we know we have to put a coefficient of 2 here to accommodate these 2 2s. Now the question is it soluble in water or not? And when we go to our list, potassium is an alkali metal. Everything that potassium's with is going to be soluble, so that's not going to form a precipitate. So the question is whether the barium carbonate could form a precipitate. Remember, we're not going to write ion charges in real equations. I'm just doing that to help you see how to put them together. Let's see what we got going on here. Carbonates. Alkali ions or ammonium ions are always soluble when they're with carbonate. Anything else is going to be insoluble. So the barium carbonate is going to be the one that forms our precipitate, and that is how you do double replacement or displacement reactions.